I didn't think that. So you see the old manage with the students trying to record for it, or not, like saying you record. No, I'm just saying they covered for you. Yeah, so it must at least like you, I suppose. Alright, next page. Okay. Is Susan in court? I know she said she'd be absent today. All right.
Like your stars within gone.
Yeah. I still have Ali, so it's some comfort. It's okay. Okay, is that a good reason?
Yeah.
I hope so. Okay. So, hey, listen. Hey, Carl, let's hang, come on. So this this next exercise, there's no new rules. What we're trying to do is use the rules we have to prove certain results. So I'll do some examples so you can try and get an idea about how these go. So 1A, for example, would say prove 1 plus tan squared x equals sec squared x. So there's basically two approaches you can take. You can start at the left and try to get to the right, or you could start at the right and try to get to the left. Or actually, sorry, there's three ways. Or you could take both sides together and try to get to something which is definitely true. So what I'll do, I think what I'll do here is I will keep it all together. So this is the same as 1 plus sine squared x over cos squared x. I want to show that this is equal to sec squared, which is 1 over cos squared x. But 1 is cos squared x over cos squared x plus sine squared x over cos squared x equals 1 over cos squared x. So this here is cos squared x plus sine squared x equals 1 over cos squared x. But of course cos squared plus sine squared is 1, so you get 1 over cos squared x equals 1 over cos squared x, which you can see is definitely true. So that will finish the proof there for this one. Yep. Here, that's what 1 is. 1 is the same as cos squared over cos squared. Yeah?
So we either have to prove...
you have three ways to do it. So you can start at the left and go to the right, or start at the right and go to the left, or keep them together and get to something which is clearly true. I'll do another example, which I'll do a different way. So that was 1A. Can I scroll down? Luke, focus please. Can I scroll down? Yeah, okay, so if we look now at 1C, I want to show that sine pi over 2 minus x equals cos x. So I think in this example, it would be much better if I start at the left. So sine pi over 2 minus x equals, well, this is the same thing as sine a minus b, isn't it? So that's just sine a cos b minus sine a cos b, or in other words, sine pi over 2 cos minus cos x minus sorry, that should be b here and cos a here, sine x cos pi over 2. But cos pi over 2 is 0, so that's gone. And sine pi over 2 is 1, so that's gone. So you're left with equals cos x, which is what you wanted.
Is sine pi over 2 0? No.
It's 1. Yeah. Okay, so write that down. Okay, can I go to the next example then? Yeah. So next example, we'll say we'll do 1f. And you want to show that sine squared x equals 1 minus cos 2x all over 2. So I feel in this example it's probably better to start with the right, because I can see what formula I can use on the right, because I have a cos 2x. So if I start on the right, I have 1 minus cos 2x over 2. That equals 1 minus bracket cos squared x minus sine squared x all over 2. That equals 1 minus cos squared x plus sine squared x over 2. But cos squared x equals 1 minus sine squared x. So if I put that, if I put that result in, I get 1 minus sine squared x plus sine squared x all over 2. So here this is 1 minus 1 plus sine squared x plus sine squared x all over 2. So this is 2 sine squared x over 2. So this is sine squared x, which is what you wanted. Because I said at the start, you can see there, show it's equal to sine squared x. So there you go, that one's done there. What's wrong, Tanish? Question? What?
They're saying how much you love these types of questions. Because they're tough, but they're good.
Yeah. I don't even know what to say to that. Alright, let's look at one now. Let's get one a bit more difficult.
How did you get the
How do I get which part?
Oh, you just added 2.
Yeah. How do I get to here from here, is it? Or?
No, like this line, the line around. Yeah. That's the part they get.
Those ones cancel, and here's 2 sine squared.
Yeah.
So that's 2 sine squared over 2. Yeah? It's okay? Okay. I want to give you one to try, and then I'll do it on the board. So what did I just do? I just did 1f there. Okay. Can I scroll down? So let's see. Why don't you try 1q, which is sine 2x equals 2 tan x over 1 plus tan squared x. Yeah, why don't you try to show this one?
Plus or minus?
Plus. So I want you to try to prove this. Is Sherry in court?
Yeah, sure.
Yeah. Antonita, do we know? Don't know.
In between Thursday and Fourth.
Okay, does anyone have this proved? Yeah. Some people do. So what did you do? Did you start at the left or the right?
Right.
Yeah. I think the right is much easier to start with. So you have 2 tan x all over 1 plus tan squared x. That's 2 sin x over cos x all over 1 plus sin squared x over cos squared x, which is 2 sin x over cos x all over cos squared x over cos squared x plus sin squared x over cos squared x. Which part? Here to here? Well, 1 is cos squared over cos squared.
No, top one.
How I got this?
The numerator.
Oh. Tan is sine over cos.
Okay.
Continue? So here, this is 2 sin x over cos x all over cos squared x plus sine squared x over cos squared x. So this is 2 sin x over cos x divided by cos squared x plus sine squared x over cos squared. But what's cos squared plus sine squared? Well, that's 1. So you have 2 sine x over cos x divided by 1 over cos squared x. So that's 2 sine x over cos x multiplied by cos squared x over 1. So this cos cancels with the square, and you're left with 2 sine x cos x, which is sine 2x. Daniel, focus or get out. Okay, so that's that one. Let's give you another one. Can I scroll down? Just a little bit. So, let me give you a tricky one to try now. I want you to, this is 1z, I want you to show that tan x over 2 is the same as tan x over 1 plus square root 1 plus tan squared x. So try this one for me. Yes. Oh, you're taking them together as you move down, yeah? Well, I can see right here. This cos squared, you move it up here. It doesn't move up because it used to be in this as well. Well, it needs to be all over cos squared for the cos squared to move up, which is not here. Yes, yes. Yeah, it's good. Yes. Yes. Yeah. No. Cos pi over 2 is 0, so that's gone. And sin pi over 2 is what? For tan x? Tan x over 2. Tan x all over 2? Or, sorry, tan x over 2 there? No. Does anyone think they have it? Did anybody manage to get it? No? But you said not yet, which means you believe you'll get to it. Are you sure that's right? Okay, I think I'll do this one now, yeah? Luke, did you get it? No? No? It's tricky, So look and watch carefully, please. So what I'll do is I'll start off with a substitution here. I'll say let x over 2 equal a. Therefore, x equals 2a. And I'll start with the right. So I have tan x over 1 plus root 1 plus tan squared x. That's equal to tan 2a all over 1 plus square root 1 plus tan squared 2a. Now you have a formula for tan 2a, don't you? It's 2 tan a all over 1 minus tan squared a. And this is 1 plus square root 1 plus tan 2a squared, which we have as tan 2a over 1 minus tan squared a. To make this a little bit quicker to write, what I'll do is I'll just say let t equal tan a, just to make it a bit shorter. So then this becomes 2 over t 1 minus t squared all over 1 plus square root 1 plus 2t over 1 minus t squared, and then this is in brackets and it's squared. Okay, so let's clean this up a little bit. So this is 2t over 1 minus t squared divided by 1 plus square root 1 plus, and this here would be 4t over, sorry, not 4t squared, 4t squared all over 1 minus t squared squared. I just put the square in here. So this is 2t over 1 minus t squared divided by 1 plus square root 1 minus t squared squared over 1 minus t squared squared plus 4t squared over 1 minus t squared squared, like that. So what I did there was I changed the 1 into this. And the reason for doing that is so that I can put these together now. So that's 2t over 1 minus t squared divided by 1 plus square root 1 minus t squared squared, and then you have 1 minus t squared squared plus 4t squared. So let me open up the top. What's nice is the square root and the square cancel in the denominator, so at least that's 1 minus t squared by itself. And if I expand the top, I'll get t4 minus 2t squared plus 1 plus 4t squared. That's 2t over 1 minus t squared divided by 1 plus t4 plus 2t squared plus 1 all over 1 minus t squared. Sorry, and I dropped my square root there on the top. 2t, 1 minus t squared divided by 1 plus, and if you look here, this is actually the same as t squared plus 1 squared, square root, all over 1 minus t squared. So the square root and the square cancel, yes? This was there. Here, where? Here? This and this go together to make this. 2t over 1 minus t squared divided by 1 plus t squared plus 1 over 1 minus t squared. So you see it's starting to simplify now. 2t over 1 minus t squared divided by 1 minus t squared over 1 minus t squared plus 1 plus t squared over 1 minus t squared. So they can go together. One minus t squared, and this is 1 minus t squared plus 1 plus t squared. So that's great because the t squareds will cancel. 2t over 1 minus t squared divided by 2 over 1 minus t squared, which equals 2t 1 minus t squared times 1 minus t squared over 2. So that cancels with that and that cancels with that, so you're left with t. But what was t? Tan a. And what was a? X over 2.
Can you do it without substituting x over 2 with a?
Possibly, but with much more difficulty.
Can you move on? Can you try it?
I think I've done enough here.
I don't even remember where I stopped.
How far back do Can you still see that?
Yeah. Oh my god. Damn. It's a little bit. Well, what is up?
Wait, slow down. Yes.
Is this a whole example?
Yeah, that's Is that how I remember it?
The exam, this will be the most difficult.
What would be the, is that how it comes?
The bonus question.
That was actually
if it came up in the exam, it would be like for 6 or 7 March.
any
Section minutes.
with another question after.
Yeah, itself was almost a half of the math question.
Yeah, I think, hey listen, I think if this was in the exam, it'd be in section B, and the way the question would be phrased would be, this would be part one of the question, would be to show this. Okay, so that would be part one, would be to show that. And then part two of the question would be to integrate like 0 to pi or whatever, your tan x over 1 plus square root 1 plus tan squared x, or something like that, where you have to use this result. Okay? But it won't, I mean, this is the most difficult example. It's the last question on the page. And the reason I'm doing it is showing you that, you know, if you could do something as difficult as this, then there'll be no problem for you in the exam. But in terms of exam difficulty, focus please here. In terms of exam difficulty, these previous questions I did, like this one here, I think this one really is what it will look like in the exam. This will be a typical exam difficulty question. This one here is much more difficult than normal. But I don't think it's impossible for the exam. I still think you could get something like this for the exam. Okay? So write this one down, please. That's not the only way to do it as well. Scroll up. How far?
Yeah, farther. Yeah, okay.
Is that recorded?
Yes.
It's recorded.
How long have you been here, Charles? Before this?
You didn't do the recording thing yesterday.
No, I did. Yes, that's right, because I was using a pen on the board. Yes. Yeah, I didn't do it yesterday. No, but there's a video there from last year's.
Steven, most of your video last year has been found out.
Yeah, but I told you, if there's not, you need to email me so I can replace it with one that has sound. Yeah. People don't listen to me. It is true. Can I scroll down?
Is there another question?
Yeah, if you want one that looks like this, you want to look at maybe the last few, X, Y, and Z.
If you write the paper, this will come up.
I didn't write the paper this year though. No, I can't. Come on, what's taking so long? That's the start of the question. No. I'm just going to leave it here, okay? Are you writing this down? You have it? Okay. Did you write this down? Hamish, did you write this down? Write it down.
I love this.
Lynn said it. He said that he's retired.
No.
The teacher.
So the reason I did the examples that I did was to try and show you a spread of the different ways you can approach it. So my first example, I think I kept both sides and carried them down. In my second example, I started at the left and moved to the right. In my third example, I started at the right and moved to the left. And in my fourth example right here, I used substitution with the angle to try and simplify it. My advice is, just a moment. My advice is, if you have an x over 2 or something like this, you should make a substitution. Let a equal x over 2. It makes it a little bit more manageable. Okay, what's your question, Pat? Yeah, so it was good to let me finish. Okay, so what I'd like you to do for the last few minutes is to practice and try some of these. Yes? Question? What? On this or? Yeah. Go up? Yeah. That's because I used the formula for tan 2a. You have a formula for tan 2a. What? I know that's not a square root of tan 2a. Look, Joshua, here's tan 2a, yes? And here's tan 2a squared. So I put in the formula for tan 2a here and tan 2a here. Squared. Because it's squared. Scroll down. Yes. Right, try these for a few minutes, please.